Take a few minutes to think about how you would describe the difference between a dog and a cat just from looking at them. Talk to your neighbor and see what they think. When you were little and you saw something cute and fuzzy, your mom or dad pointed to it and said dog or cat, giving each sighting a label. You didn't always know the difference, but after repeated exposure to those labels, dog or cat, something in your brain connected. Machine learning is a type of artificial intelligence that allows computers to learn from examples, like how you learned the difference between a dog and a cat. Machines use labeled data, just like dog and cat, to recognize patterns. Machines learn to tell a dog from a cat by looking at thousands and thousands of labeled pictures of dogs and cats. Like your brain, a machine gets better at identifying things by digesting lots of labeled examples. And over time, it can identify new things it hasn't ever seen before. Machines can find patterns that humans can't always identify with words. And after their training, they can make predictions. Hey, this picture looks like a cat. Machine learning helps in real-world tasks by recognizing patterns and making predictions. YouTube and streaming services suggest programs you might like based on what it has learned from your viewing habits. And Amazon makes suggestions based on products you've searched. You add training data for self-driving cars each time CAPTCHA asks you to click on pictures which contain taxis or stop signs or motorcycles. And when you interact with Siri or Alexa, you're training those voice assistants to understand your speech. And just like how you learn to recognize a dog from a cat, machines learn from seeing tons of examples and making connections and predictions. Teachable Machine is a simple tool that lets you train a machine learning model by showing it examples.
Hi, I'm going to show you how to train a model with Teachable Machine. Like all machine learning workflows, you first need to gather data. What you see here on the left are what we call classes. Each of these represents a different category you want to teach the computer to recognize. So let's try adding data to our first class. I'm going to call this one neutral. And you have two options here. You can upload files from your local computer or use a webcam. Let's use a webcam. Hit record and it can start collecting images. You can see that I'm moving around here to add variety to my data set. Let's try adding data to our second class. I'm going to call this one dog. Again, I'm going to hit webcam and try to get data from this stuffed animal. You can again see that I'm moving it around to collect some variety. Now that we have enough data, just click on this button to get started with the training. Because the training is happening locally on your computer, you need to make sure to keep this tab open. Another trick is to move the tab onto a separate window. Once the model has finished training, you'll see this preview panel expand on the right. If you add more data to the model, you'll have to retrain it. When the model has finished training, you'll see this preview panel expand on the right. At this point, you can start experimenting with this and see if it works. Neutral, dog, neutral, dog. These bars here represent the confidence that the model has in predicting different categories.
Before we get started, let's talk about how this works. First, we have to label our categories. We're going to train our model to recognize facial expressions. We'll use 3 data classes. They'll be labeled smiling, frowning, and surprised. Using the webcam on one laptop per group, the 4 members will take turns recording each other, first with a smiling face, then frowning, and surprised. This is the step 1 of the machine learning process called collecting labeled data. The machine learning model starts by taking in the labeled examples you've provided and tries to find features, important patterns or characteristics that define each category. The machine uses these extracted features to build a mathematical model, essentially learning the relationships between the features and the categories. This process involves a lot of trial and error, and the machine compares its prediction to the correct label and makes adjustments to minimize its mistakes and learn from its errors. This happens thousands or millions of times during the training. And while we know it's adjusting based on errors, it's hard to explain exactly what each layer of calculations is learning, especially in more complex models, which is why you may have heard this process referred to as a black box. After training, the machine gives a prediction along with a confidence percentage. The confidence percentage tells you how sure the machine is about its prediction and how much you should trust it. I'm sure that you've all heard concerns about unconscious bias in artificial intelligence. In recent years, machine learning algorithms are being used in industries like healthcare, finance, criminal justice, facial recognition, HR and hiring, and many others. Across these industries, bias can be mitigated by using more diverse data sets, implementing fairness checks in models, and creating transparency in how algorithms make decisions.